In this video, we're going to look at the exact values of the primary trig ratios for angles 30, 45, and 60 degrees because those angles are commonly used. So let's start with the 45 degrees. We're going to focus on this isosceles triangle here with equal side lengths of 1 unit. Okay, it's a right angle triangle. And because it's a right angle triangle, that means both of these angles here have to equal to 45 because the sum of all the angles have to add up to 180, and these base angles in the isosceles triangle have to be equal. So 180, when we take away 90, leaves us with 90, and split evenly between these two angles makes the angles 45 degrees. In addition to determining these angles, we're going to also determine the length of the hypotenuse using the Pythagorean theorem. So I know that c squared is equal to a squared plus b squared, with c being the hypotenuse, and that's what we're looking for. A and b are the two shorter sides, and in this case, they're each 1 unit in length. When I evaluate the right side, I get 2. And that's what c squared is equal to. So to get the length of the hypotenuse, which is just c, I have to take the square root of 2. And I'm going to leave it as a root because it's an exact value, represents an exact value. I'm not going to rewrite it as a decimal and round to 2 decimal places. So next I'm going to label the sides of my triangle here using the words opposite, adjacent, and hypotenuse. I'm going to use this 45-degree angle. So in relation to this 45, this is the opposite side, this here is the adjacent, and this is the hypotenuse. Now I can fill in the table for the 45-degree angle. I know that the sine ratio is the ratio of the opposite side and the hypotenuse, so it's the ratio of 1 to root 2. For cos, it's the ratio of the adjacent side and the hypotenuse. So again, we'll have 1 over root 2. And for tan, it's the ratio of the opposite side and the adjacent side. So we have 1 over 1, which just simplifies to 1. And now let's look at the other angles of 30 and 60 degrees. For these angles, I'm going to use the equilateral triangle that I have drawn here with side lengths of 2 units each. And in an equilateral triangle, all the angles are equal, and since they all add up to 180 degrees, I know that each one of them has to be 60. 180 divided by 3, or split evenly between them, gives me 60 degrees. And next, I'm going to split this equilateral triangle into 2 right angle triangles and only use one of them. And I'm going to choose the one on the left, making a right angle triangle here. So since I cut the base here in half, that means the horizontal side now is 1 unit in length. And since I cut the angle up top in half, the angle at the top in my right angle triangle will be 30 degrees. Okay. And I'm going to just erase the left side here. And next I'm going to calculate the length of the vertical side using the Pythagorean theorem again. So I have c squared is equal to a squared plus b squared. This time I'm only interested in one of the shorter sides. So if I want to get a squared by itself, I have to subtract b squared from c squared. And c is our hypotenuse, so subbing in the value, I get 2 squared. And for side b, it's going to be the one that measures 1 unit. So I end up with 3 when I evaluate the right side. And that's a squared. So when I take the square root of it, I get the square root of 3. And that's the exact value for this vertical side. Okay. And now I'm going to label the sides using the words opposite, adjacent, and hypotenuse again. And let's start with the 30-degree angle. In relation to the 30-degree angle, this is my opposite side, this is my adjacent side, and this is my hypotenuse. So let's fill in the table next. For sine, it's opposite over hypotenuse, so it's going to be 1 over 2, or 1/2. For cos, it's adjacent over hypotenuse, so it's root 3 over 2. And for tangent, it's opposite over adjacent, so it's 1 over root 3. Okay. Now I'm going to focus on the 60-degree angle. I have to relabel my sides. The hypotenuse will stay as 2, but in relation to the 60-degree angle, this is now my opposite side, and this is the adjacent side. Now I'm going to fill in the table here. So sine is opposite over hypotenuse, which gives me root 3 over 2. Cos is adjacent over hypotenuse, giving me 1/2. And tangent is opposite over adjacent, giving me root 3 over 1, or simply root 3. Okay. Now let's look at the table here. First of all, we see roots in the denominator, which we normally don't like to do, because if we have to simplify things when we're adding fractions containing roots, we don't like to see those roots in the denominator. Okay, so we oftentimes what we do is we rationalize the denominator. So how do we do that? We multiply the fraction with the root in the denominator by 1, and that 1 would be equivalent to the denominator's root over that root. So we're going to multiply by root 2 over 2 because we see a root 2 in the denominator. Root 2 over root 2 is just 1. 1 multiplied by this fraction is still equivalent to that fraction. And when I multiply my numerators, I get root 2. When I multiply my denominators, I just get root 4, which is equivalent to 2. So this is equal to root 2 over 2. That means this will also be equivalent to root 2 over 2. If I want to get rid of this root for tan, I would simply multiply it by root 3 over root 3 to give me root 3 over 3. Okay. Now these are values that you have to kind of commit to memory. You either start with the triangles that I drew here and come up with them, or you memorize the table. And there's a pattern in the table. For example, root 1 can also be written as, 1 over 2 can also be written as root 1 over 2. So look at the pattern here. We have root 1 over 2, root 2 over 2, root 3 over 2. For cos, we go in the opposite direction. This is the same as root 1 over 2, root 2 over 2, root 3 over 2. For tan, the way that you can obtain the answer is you can divide the values in the sine column by the values in the cosine column. So root 1 over 2 divided by root 3 over 2 would give you 1 over root 3. And then you can rationalize it. Okay, here root 2 over 2 divided by the same value of root 2 over 2 gives you 1. Root 3 over 2 divided by 1 over 2 just gives you root 3. If you can't see that, I'll just show you with root 3 over 2 being divided by 1/2. When you're dividing by 1/2, remember you're multiplying by the reciprocal. The reciprocal 1/2 is 2 over 1, and then they will cancel, leaving you with root 3 over 1 or just root 3. Okay? Now let's use this chart to answer some questions. So sometimes you'll be asked to find exact values of expressions. So in this particular example, it says determine the exact value of the following expression. And the first one is sine 45 times cos 45 plus sine 30 times sine 60. And you're supposed to do this without a calculator. So if you look at the chart, we have in our chart sine 45 is root 2 over 2. So we're going to sub that in, root 2 over 2. And we're going to multiply that by cos of 45, which looking at the chart is again root 2 over 2. To that, we're going to add sine of 30. And sine of 30 is simply 1 over 2, or 1/2. And we're going to multiply by sine of 60. And sine of 60 is root 3 over 2. And from here, you just perform all the mathematical operations in the expression. So first we're going to multiply. So we're going to multiply the numerators and multiply the denominators. Root 2 times root 2 is root 4, 2. 2 times 2 is 4. Now for the second part, we're going to multiply the numerators, giving us root 3, and the denominators giving us 4. Since our denominators are already the same, we just combine our numerators, keeping the denominator the same. And this would be our final answer, because these are obviously have a constant and a radical, and we don't have like radicals to simplify, so you leave the answer as this. So this is the exact value of that expression. Here's another one, says tan squared 30 plus cos squared 60. And what tan squared 30 means is that you're multiplying tan 30 by tan 30. And then cos squared 60 means you're multiplying cos 60 by cos 60. Okay. And the reason we don't put the squared after the 30 or the 60 degrees is then it looks like the angle's being squared, not the ratio. So this is why we write it like this. Now we're going to sub in the values. So for tan 30, if you look over here, root 3 over 3 is the value that I'm going to sub in. For cos 60, it's 1/2. Okay, so 1/2 times 1/2. Now multiplying the numerators, root 3 times root 3 is just 3. 3 times 3 is 9. Here we have 1 times 1 or 1, and then 2 times 2 or 4. Now 3 over 9 can be reduced to 1/3 if you want to work with smaller numbers. And now we need to find the lowest common denominator, because we're adding fractions, which in this case would be 12. And since I multiplied the 3 by 4, I have to multiply the 1 by 4. So 4 becomes the numerator of my first fraction with a denominator of 12. And here I would get a numerator of 3 since I multiplied the 4 by 3, and now I have to multiply the 1 by 3. Now, combining my numerators, keeping the denominator the same, the exact value of tan squared 30 plus cos squared 60 is 7 over 12. Okay. We also work with these special angles when we're solving linear trigonometric equations. So this is an example of it. It says determine theta if theta is between 0 and 90 degrees, given that 2 cos theta is equal to root 3. So we need to, first of all, isolate cos theta and get it by itself. So to do that, we just simply divide both sides by 2. And that leaves us with cos theta being equal to root 3 over 2. And next, because we know the exact value from our table, is root 3 over 2 here for an angle of 30 degrees. We simply write that theta is 30 degrees. You're not going to use your calculator because it's an exact value that you had to commit to memory. We also use these values to verify some type of identity here, or property. So all we have to do here is show that cos 30 over sine 30 is really equal to 1 over tan 30. So we're going to divide this into a left side and a right side and substitute the exact values. And then we're going to evaluate each side separately and see if they end up with the same answer. And as they should, because we're just verifying it. So we have cos 30 divided by sine 30. I'm going to write it like this because it's easier to manipulate it this way. That's my left side. My right side is 1 divided by tan 30. I'm going to sub in the exact values. So if I look again, cos 30 is root 3 over 2. Sine 30 is 1 over 2. So root 3 over 2 divided by 1 over 2. Okay, here I'm dividing, so I can change that to multiplication and multiply by the reciprocal of 2 over 1. The 2's cancel, leaving me with root 3. On the right-hand side, I'm going to sub in for tan 30, root 3 over 3 or 1 over root 3. I know that my answer should be root 3, so I'm going to use this one, but you can use this one as well. Okay, so 1 over root 3. And I'm going to multiply by the reciprocal, which is simply root 3, giving me root 3. So I just showed that the left side is equal to the right side, so the expression cos 30 over sine 30 is equal to 1 over tan 30. Now, if you decided to use, for example, root 3 over 3 instead, it's a little bit more work. Taking the reciprocal, get 3 over root 3. Oh, sorry, I have to change that to multiplication. So 3 over root 3 like this. Okay, now you can either realize that 3 is equivalent to root 3 times root 3, and then the root 3's would cancel, leaving you with root 3. Or an alternative would be to rationalize the denominator by multiplying by root 3 over root 3 to give you 3 root 3 over 3, and then the 3's cancel, leaving you with root 3 again. So regardless of which way you do it, you should get the same answer.